Hey there, everybody. Welcome back. We are working in Calculus 3. This is multiple integrals over non-rectangular regions. I've got more examples for you. In this case, we're going to evaluate our function f of xy is x plus 2y. We're going to do it over the region bounded by y equals 2x squared and y equals x squared plus 1. So if we plot them both, we can see what our region looks like. It's kind of like a necklace. It's the in between these two curves. And so we want to look at the two different ways we can integrate. If we integrate along dx first, the stuff in red, I'm going to have to break this up. I'm going to have to do we've got 0 to 1 first, this bottom half, where our lower boundary is negative 1/2 y squared, or no, I'm sorry, negative square root of 1/2 y, and the upper half is the positive square root of 1/2 y. And this is just by solving for x in each of these. Solving for x here. And then when we get to 1 to 2, we've got two areas. I've got to go from the negative square root of 1/2 y up to the negative square root of y minus 1. And then we restart the integral at the square root of y minus 1 up to the square root of 1/2 y. So one integral for the lower half, two integrals for the upper half. We've got three integrals. Okay, good to know. Let's check out what we do if we got integrate from dy first. So it's only going, looks like only one region. No matter where I go, we're doing y first along any column of x, and I can see that no matter where I'm going upward, it's the same lower function to the same higher function. So we're going from 2x squared is less than y up to x squared plus 1. And we've got our x's bounded by negative 1 to positive 1. Let's go with that one. We set up our integral. As a reminder, we're doing the integral we want to do first on the inside. So I put x plus 2y on the inside, dy, that's always on the inside, but I did dy first. And make sure you've got the limits of integration in the right order. The dy matches up with the y limits. So good to go here. We integrate, x plus 2y becomes xy plus y squared. We evaluate at our limits. I wrote out a couple steps because there's a lot of stuff to clean up here. So I plugged everything in, then I multiplied everything out, and then I collected like terms. Then I finally integrated. So we've got negative 3/5 x to the 5th minus 1/2 x to the 4th plus 2/3 x cubed plus 1/2 x squared plus x. And we're evaluating from x equals negative 1 up to x equals positive 1. We plug all that in and check through the math. We get 32 and 15. Again, pause and verify my work. Maybe work it out yourself to verify you got it right. I don't want to make this video too long if I don't need to. And you guys know how to plug stuff in and do algebra theoretically. Okay, I'll assume you paused it and did that. I wanted to point out, notice how switching the order of integration is no longer as simple as swapping spots, like for rectangular region. In the last video, in the last section, we were able to just change the order. Now we got to rethink the lines. Most of the time we have it listed in terms of one variable, like here, y. But if we want to switch to x, we need to see what it's going to look like in x as well. So they will lead to the same solution, but choosing which variable to integrate with respect to first can actually save you a lot of time. So let's just take a look. Well, as the last one showed you, we would have done 3 integrals. Let's take a look at this one. We're going to evaluate the function x times y, and the region we're bounding it by is y equals x minus 1 and y squared equals 2x plus 6. So I drew out what they both should illustrate, what they look like. We've got y equals x minus 1 here. If I list this y as it should be, we've got the positive square root of 2x plus 6 on the top half, and the negative square root of 2x plus 6 on the bottom half. So if we just look at it pictorially, we can see some regions have more integrals. So if we're doing dy first, I've got to go on to the left of this line. To the left, it looks like -1. I've got to go from the negative root up to the positive root. And then when I get to -1 over to, looks like 1, 2, 3, 4, 5. -1 to 5, I got to go from x minus 1 is now our lower line, and we're still going up to the positive square root of 2x plus 6. If we integrate along x first, we can see that the x minus 1 is always the upper line, and the lower line is always that square root. In fact, if I'm writing it in terms of x, I subtract 6 over, divide by 2. And that turns into 1/2 y squared minus 3, as I've got listed here. Okay. So there's less integrals by integrating x first, and neither of them looks harder than the other. In fact, I like the lower limits better because I have polynomials, not square roots. I don't like square roots in the limits if I can avoid it, if you can avoid it. But we're integrating xy across dx dy. So we did x first here, 1/2 x squared y, evaluating from x equals 1/2 y squared minus 3 up to x equals y plus 1. Plug it in, we get that. Clean it up, it looks like this. I factored out the 1/2 and I moved the y in. Here I just pulled out the 1/2 and the y, put it out front, and then just did x squared of each of these. So x squared of y plus 1 being squared is that. 1/2 y squared minus 3 is that. Okay. We go through, integrate with now with respect to y. You know how to do this. It's Calc 1 material. We finish it up, we get 36. So picking how we do it can save us some time. Peace.